the given integral belongs to integration by partial fraction case 2, some repeated distinct linear factors. The first question that you will ask me is, hey, x squared plus 1 is not linear. It is repeated, but it is not linear. So how do we get the linear factors? Take a look one more time. X squared plus 1 can be factored into two distinct linear factors. So let's do it. So first of all, I put the square to x squared times minus 1 times itself. And then for each x squared minus 1, we can factor it to two distinct linear factors. X squared plus minus 1 is equals to x minus 1 times x plus 1. This is for 1 x squared minus 1. What if that is x squared plus 1? Then it cannot be factored. If that is x squared plus 1, that belongs to another case, which is what we are going to discuss next. And then the second x squared plus 1, so that gives you two more linear factors, dx. So now we have two of this, x minus plus 1 square and x minus 1 square dx. X, they are distinct and they are both repeated. Okay, they are distinct linear factor and they are both repeated. So we need two letters for each linear factor. So the given integral, 1 divided by, or should say the given integrand, x squared minus 1 square. So for the plus, we need to use a and b, 1 for the first power and 1 for the second power. Same thing for the x minus 1. C for the one letter for the first power, and then one letter for the second power. All right, and then this one, let's get the common denominator. So 1 is equals to a, and then for a, we have 1x plus 1. So we need one more, and we need 2x minus 1. For b, we already have 2x plus 1, so we need 2x minus 1. For c, we have 1x minus 1. We need one more x minus 1 and 2x plus 1. For d, we already have 2 minus 1, so we need 2 plus 1. We have 2 of this already. Oh, sorry. We have 2 of that already, so we need 2 of this. And then this one, we can try convenient values. So let's try x is equals to -1. So when x is equals to -1, all the plus 1 will be gone. So we have 1 equals to no a, because -1 plus 1 is 0. The b, -1 minus 1 is a -2. -2 squared is equals to 4. And then for the c, when x is equals to -1, the plus 1 makes everything 0. And then for the d, the plus 1 makes everything 0. So 1 is equals to 4b, and b is equals to 1/4. I just got this without any system or any equating coefficient. And then what about x equals to 1? When x equals to 1, all the x minus 1 will be gone. So there is no a, there is no b, there is no c, you only have d. So d, 1 plus 1 squares, then you have a 4d. Then d is equals to 1/4. And then what about x equals to 0? I know x equals to 0 is not a convenient value. Since we have 4 letters, I do want to reduce this a little bit. So what if x is equals to 0? So we have 1 equals to, we have 0, 1 times 1, which is 1, so we have a, and then b, 1 times 1, we have a minus c, and then for d, we have positive d, and then we plug in b and d, so 1 equals to a plus 1/4 minus c, and then plus 1/4. So we have 2/4 and 1 minus that, so we have 1/2 equals to a minus c. It looks like we have to do more work to get the to get the A and C. So using the convenient value, I can get D and B, but need some work to do this, to get the A and C. I know this is not easy. It takes a lot of practice. Okay, can we do some equating coefficients? Our target is A and C, right? I need A and C. So A is here, C is here. That is my target. I already know B and D. Okay, how about this? For A and D, the constant value is 1. How about we use the third power? Let's write this down. Let's do this in another color. Let's give me a better comparison. Equating coefficient for what? For x to the third power. How do we get a third power? Look, we have x, and then we have x to the second power, and then this one we have x, and then x to the second power. So that's how we get the third power. And then do we have third power on the other side? The answer is no. So on the other side of 1, do we agree that there is a 0 x to the third? So that is equals to 0. What is the coefficient of x to the third for the A? So we have to open up the square. You are looking at here right now. Look at my cursor. We are looking at the A. So for the A, we have x raised to the second power, that is second power, times another x, that gives you x to the third, and then times A. So basically, you have A times x to the third. And then for the C, you have a plus C x to the third, right? And then after you factor out x to the third, you have A plus C. So that means the 0 is equals to A plus C. All right? Should we do this again? I heard yes. Okay, let's do this again. On the line right here, look at this line, line 1. On the left-hand side of the equal, there is no x to the third. So that is 0 times x to the third. That's how you get the 0 out. And then on the right-hand side, I am targeting A and C. And the A and C can give me x to the third. Because for A, you have x to the second power. So that is second. And then multiply one more x, you get x to the third. Multiply the A, you get ax to the third. I don't care about the rest of the terms because I only need x to the third. And then for the C, same thing. X to the second power times x times c, you get x to the third. They are both plus, right? There is a plus right here. So, and then you factor out the x, you have x to the third times a plus c. So that's how you get the 0 equals to a plus c. And then you let the other formula join the game. You have 1/2 equals to a minus c. You let this formula join the game. And then let's solve this system. Let's do a minus. 0 minus 1/2 is negative 1/2. A minus a is gone. C minus negative c. Minus minus is a plus, so we have a 2c. And then once we divide both sides by 2, c is equals to negative 1/4. And then you have 0 equals to a minus 1/4. Then a is equals to 1/4. So now I got a, b, c, and d. All right. And then where do you plug in the a, b, and c? A, b, c, d. So you plug in the a, b, c, d back in this line. This line right here. The line where I put a star right next to it. All right. Let's do the plug-in. Okay. Let's go back to yellow. And then we do the plug-in. So for the a, we have a 1/4 divided by x plus 1 dx, so that is an ln, and then plus 1/4. This is, we have x plus 1 square dx, and then the c, we have negative 1/4 x minus 1 dx, and then the d past 1/4 x minus 1 square dx. And then this, the first one gives me 1/4 ln absolute value of x plus 1. And then the last one gives me 1/4 L. Oh, that's not it. And then the third one, minus 1/4 ln absolute value of x minus 1. Okay, what about the square in the bottom? The square in the bottom, so think about this. If you let u equals to x plus 1, du is equals to dx, right? So you are like integrating 1 over u square du. So this is integrating u to the negative 2 du, which is negative u to the negative 1 du. All right, so all you have to do is you put the 1 over 4 right there. And then the u, this will be x plus 1 to the negative 1. And then I believe that this is a plus, right? So this is, oh, haha, there is a negative right there. So that is a minus. There is a negative right there. So this negative will carry over there. So that will be a minus. All right. And then the last one, same thing. So the last one will be minus 1 over 4 parenthesis, but you have an x minus 1 inside. And then you add c to it. So let me double check my work. Negative 1 over 4. 1 over 4 ln absolute value x plus 1 minus 1 over 4 ln absolute value x minus 1. And then we have a minus 1 over 4x plus 1 and then a minus 1 over 4. Yep, that is the final answer to this problem. Okay, and that is also the end of this video. If you think I picked the best problem and gave you the most clear explanation ever, give me a like, subscribe, share the video for me. Appreciate for your help and support. See you all in the next one. Signing out for now.